Greetings, all the students. I hope you all are doing your exam preparations. The exams are very near around the corner. So some of you must be struggling with some basic things in chemistry. So I'm today doing some of the topics, and these topics are uh, how to calculate how to write down the chemical formula, what is a chemical formula, how to write down the chemical formula, how to calculate the formula mass, relative formula mass, percentage of a particular element in a chemical formula, in a chemical compound, how you will calculate the percentage of a particular element, and balancing of chemical equations. So we are going to do this thing today. I hope this video will be helpful for your exam preparation. Watch carefully. So let's start with writing. Before writing the chemical formula, let me tell you that in order to write down the chemical formula, what are the things you will be needing? All right. So before doing this thing, in order to write down the chemical formula, the things you require. All right. Number one, you require the symbols of the elements. What are symbols? Symbols are the short forms of the name of the elements. For example, the short form of the hydrogen is H. The short form of silver is Ag. So from where we are going to get these things? We are going to get these things from the periodic table. We are going to get this thing from the periodic table. So the periodic table is the list of a table in which all the elements which have been discovered so far are put together. And in the periodic table, you will get all the elements and their symbols. Symbols are the short form of the name of the elements. The second thing you will be needing is the valency. What is valency? Valency is the charge, positive or negative charge, which appears on an element when they take part in the chemical reaction. How we will understand? Do we need to learn the valencies? No, you do not have to need. You do not need to learn the valencies. You do not need to learn the symbols. Your teacher should provide you a periodic table along with your question paper in the exam. All right. So it is not possible, humanly possible, to learn all the valencies and symbols. All right. But I ask my students to learn some of the valencies of transition elements and the radicals. They should memorize that. All right. Because in the periodic table, you will not find the valencies of the transition elements and the radicals. All right. So you can see here, I have a periodic table in front of me. So this is the periodic table. Just wait a minute. Let me share the periodic table with you. This is the periodic table, children. See. So in the periodic table, if you are doing chemistry since your class 7, 6, even 6 student also, they should know what is the periodic table. So this is the periodic table. All right. So in the periodic table, let me tell you that these vertical columns are called groups. All right. So what are those vertical columns which are called groups? You see the first one. This is the first one. This is group number 1. This is group number 1. This is group number 1. This is group number 2. This is group number 3, 4, 5, 6, 7, and 8. So these vertical columns, this vertical column is group 2. This vertical column is group 1. So this vertical column is group number 1. This is group number 3. This is group number 4, top to bottom, like this. Vertical columns are called groups. All right. By seeing the group, how you will understand? the valencies. How we will understand the valencies? By seeing the group numbers. The group number will tell you the valencies, like those which are in group number 1. They have a valency of +1. Group number 1, the valency is +1. So let me write here group number 1 +1. It means when the elements of group number 1, they participate in the chemical reaction, they all will get a +1 charge over it. How you will understand why it is happening? So gradually, slowly, when we will move to the other chapters of bonding, then you will understand. Group 2 +2, group 3 +3, group 6 -2, group 7 -1. Why I did not tell you about group 3 and 4? Sorry, group 4 and 5. Because in class 6 and 7, you will not be needing it. So we will see them later. Group number 1, the valency is +1. Group number 2, the valency is +2. Group number 3, the valency is +3. Group number 6 -2. Group number 7 -1. Those which are in the middle, they are transition metals. You will see there is no group number written over them. Why? Because they have got variable valencies. Their valencies change according to the situation, according to the chemical reaction. So that's the reason I ask my students, those who are in class 6, 7, by the time you people go to class 8 and O level, by that time you will understand that what will be the valency of the transition elements. By that time you will memorize those valencies. Okay, so it will be already memorized to you. So now let's see, let me move to the transition elements. Let me show you the valencies of the transition elements. Let me go back to my whiteboard. All right. So the transition elements, for example, the commonly used transition elements are the commonly used transition metals. They are metals, the middle one, the middle block are the metals. For example, in the question, it will be written iron 2. It means the valency is +2. Or iron 3, the valency is +3. Or copper 1, the valency is +1. Or copper 2, the valency is +2. Similarly, the valencies usually will be mentioned to you, but if they are not mentioned, then what we will do? We will take zinc +2, we will take silver +1, we will take lead. If it is not mentioned, I will take +2. We will take manganese +1, etc., etc. Okay. I hope that in junior classes like class 6 and 7, you will be not needing more than that. Okay, now we will see the radicals. What are radicals? Radicals are the group of atoms. Radicals are the group of atoms, but they are not the molecules. Molecules are group of atoms. So radicals are the group of atoms, but they are not molecules because molecules do not have any charge. Radicals have charge over them. So what are radicals? We have got ammonium. So NH4 with a +1 charge over it. Hydroxide, OH -1. Nitrate, NO3 -1. Carbonate, CO3 -2. Sulfate, SO4 -2. Phosphate, PO4 -3. So you will memorize them. There are some of the things in chemistry, in biology, understanding plus memorizing also we have to do. All right, children. So let me rub the board. And now I will move how to write down the chemical formula. If the name is given to you, you will write down the formula. And if the formula is given to you, you will write down the name. All right. So how it is given to you? For example, I have given you the name. write down the chemical formula of the following compounds. For example, I have written like sodium oxide. So remember one thing, while writing the chemical formula, the elements which are always metals and they always have a positive valency should be in the beginning of the formula. The elements which are non-metals having a negative valency will be in the end of the formula. So the non-metals, you will see their name will end into IDE. So what is actually oxide? It is oxygen. It was oxygen. But when it has participated in the chemical reaction and the charge has appeared over it, now it has become an oxide ion. You cannot say oxygen ion, oxide ion. So all the non-metals, where you will find them? You will find them in group number 6 and group number 7, because we will be needing these two important groups in writing the chemical formula. Similarly, if it is potassium sulfide, so potassium is K, and what is this sulfide actually? It is actually sulfur. Since it is a non-metal, it has participated in the chemical reaction. A charge has appeared over it. So the name is ending into IT. Sulfur has become sulfide. Chlorine will become chloride. Fluorine will become fluoride, and so on. But sometimes in the chemical formula, there are 4 radicals. When they will come in the end of the formula, their name will end into ATE, nitrate, sulfate, carbonate, phosphate. So sodium nitrate. So sodium you will find in the periodic table, but if you will look for nitrate, you will not find it in the periodic table, because nitrate is not a single element. It is a group of atoms. It is a radical. You will not find nitrate in the periodic table. It's a radical, and these 4 radicals, when they will come in the end of the formula, their name will end into ATE, nitrate, carbonate, sulfate, phosphate. And if the single non-metals are coming in the end of the formula, their name will be converted into IDE, oxide, sulfide, phosphide, carbide, like this. Remember all these things. They will be helpful for writing the chemical formula. So now let me show you few formulas. Like for example, it is given to you sodium oxide. How I will write down the formula. Sodium is Na. From the periodic table, I will see on oxide is oxygen O. Sodium is in group number 1, so it has a valency of 1 plus. Oxide is oxygen group number 6, so its valency is -2. I have just showed you in the periodic table. The formula is not balanced. Both of the charges must be equal. If this is 2, this one must be 2. How can we make it 2? Criss-cross, the easiest way. All right, why we are doing crisscrossing? When we will do the chapter of bonding, then you will understand. So now the balance formula will be Na2O. Similarly, if I write aluminium chloride, so aluminium is Al, chloride is actually chlorine. The name is ending at IDE because it has participated in the chemical reaction and a charge has appeared over it. So it has become a chloride ion. Aluminium belongs to group number 3, so the charge is +3. Chloride is in group number 7, so the charge is -1. Both of them are not equal. If this is 3, this must be 3. Criss-cross. AlCl3 is the correct formula. These are the easier ones. Now let's see a little bit different one in which we are using the radicals. All right. So let's say now I am writing ammonium hydroxide. Okay. So now the formula is ammonium is a radical, hydroxide another radical. Can these two radicals be together? Of course, one is positive, another one is negative. They can come together. So NH4OH plus 1 minus 1. I have showed you the valencies. Okay. So plus 1 and minus 1 are equal. So the balance formula will be only NH4OH. But not always. Sometimes the formula can be ammonium sulfate, for example. Again, two radicals together. So what is ammonium? NH4 with a plus 1 charge. Sulfate is SO4 with a 2 minus charge. Cross. They are not balanced. They are not equal. One is 1, another one is 2. So how I will write the balance formula? I will write NH4 bracket 2. Without bracket, if you will write 2, it looks that it is 42. It will look that it is 42. So the balance formula is SO4 and H4 bracket 2 SO4. 1 is coming with SO4. Whenever 1 is coming with anything after crisscrossing, do not mention 1. You don't have to mention 1. Nothing means 1. I hope you people are understanding. Okay. So this is how we are writing the chemical formulas. Okay. So you can check a list of the chemical formulas. You can Google search chemical formulas. It must be in your textbook. Your teacher must have done in the class. So make a list of 20-25 formulas, practice them. You will be able to understand. Now, how we will calculate RFM. What is actually RFM? RFM is relative formula mass, the mass of the entire formula. For example, the formula we have seen first was Na2O. The mass of this entire formula is called formula mass. How we will get this formula mass? We will go to the period, and for this we will be needing individual atomic masses. What is atomic masses? Atomic masses are the sum of the protons and neutrons of an element. Where you will get it? Do you have to memorize them? No. You will get them from the periodic table. All right, how? See, again, I'm showing you the periodic table. This is the periodic table. And you can see that in the periodic table with every single, let me enlarge the thing. With every element, numbers are written. What these numbers are. All right, what these numbers actually are. So these numbers are atomic masses and atomic number. All right. So you will see, for example, sodium. On the head of the sodium, one number is written, and on the foot of the sodium, another number is written. So what is this number? This number is the atomic mass. This number is the atomic number. It means in order to calculate the relative formula mass, we have to see the number which is written on the head. You are not going to see this number now. For calculation of relative formula mass, see the individual atomic masses, the ones which are written on the head. So how we will do that? Let me show you this example. Like if you will see in the periodic table, on the head of sodium, it is written 23, and on oxygen, it is written 16. So 23, but how many oxygen here after crisscrossing? 2. So multiplied by 2 plus. How many oxygen? Only one oxygen. What is the atomic mass? 16. So 46 plus 16. 62. The RFM, the relative formula mass of sodium oxide is 62. All right, this is the easiest one. Let me show you two more. For example, now we have got aluminium chloride. So your teacher has given you, write down the chemical formula and calculate the RFM, aluminium chloride. All right, aluminium is Al, chloride is Cl. Group 3, aluminium plus 3. Chloride, group 7, 1 minus. Cross. Aluminium, you do not have to write 1 with aluminium, but you must write 3 with chlorine. We will go to the periodic table and we will see on the head of aluminium, it is written 27. And on the head of chlorine, it is written 35.5. All right. So aluminium is 27 plus chlorine is 35.5. How many chlorine? 3 multiplied by 3. So multiply these two. Whatever your answer will come, add it with 27. Do it carefully and you will get your answer. Remember one thing, children, in chemistry, when you are doing the calculation, try to keep the answer up to 2 decimal places. All right. Now, let me show you a difficult one. For example, now we have got a formula to write about ammonium sulfate. All right. So if you will learn 2, 3, the rest you will be able to do yourself. Ammonium sulfate. All right. So what is ammonium? It's a radical NH4. The charge is +1. Sulfate is SO4. That is also a radical -2. Crisscross it and it will become NH4 bracket 2 SO4. Bracket 2 means this 2 goes with nitrogen and this 2 goes with hydrogen as well. On the top of the nitrogen, atomic mass is 14. Hydrogen 1, sulfur 32, oxygen 16. How we will write now? Nitrogen 14 out of the bracket 2. So multiplied by 2. Plus hydrogen 1 multiplied by inside the bracket 4, outside the bracket 2. So 4 2s are 8. Plus sulfur 32. There is only one sulfur. Oxygen 16. How many oxygen? 4. So 28 plus 8 plus 32 plus 16, 4 is the 64. Add all of them together. You will get the RFM. This was the story of RFM. So those who have got syllabus up to this much, they will learn up to this much. Those who have got in the syllabus how to calculate the percentage of a particular element in a chemical compound. Then for them, let me show you. For example, calculate the percentage of oxygen in silver nitrate. For example, your teacher has not given you the formula of silver nitrate. In order to make the thing tougher, she has given you the name. So what you are expected to do, you have to write down the formula first, calculate the RFM. Silver is Ag plus 1. It's a transition element. Nitrate, see at the end there is 8. It means it is a radical. It's not a single element. -1. The formula is balanced. +1 and -1 cancel out each other. Now we will see the individual atomic masses. Silver, if I'm not wrong, it is 107. Nitrogen is 14. Oxygen is 16. Let's add all of them together. So 107 plus 14 plus 16. How many? 3. So multiplied by 3. So 107 plus 14 plus 48. Add all of them together. Let's see what the answer. So children, when I have added them, my answer came 169. All right, now I have to find the percentage of oxygen. So what is the formula? The formula is mass of oxygen. Let me erase this part so that I can write down the formula. Mass of oxygen divided by the total RFM, and for percentage we multiply by 100. So mass of oxygen, this is oxygen. I know the mass of oxygen is 16, but how many oxygen atoms are here? Do not forget 3. So multiplied by 3. Divided by the RFM is 169 into 100. What is the answer now? 48 divided by 169 multiplied by 100. 28.40. So my answer is 28.4. I will not leave up to this much. After this, 0%. 28.40% is the percentage of oxygen in silver nitrate. Okay, check another one. This was the easier one. Let me show you a tougher one. For example, calculate the percentage of nitrogen in ammonium sulfate. Okay. So first of all, percentage of nitrogen. percentage of nitrogen in ammonium sulfate. In ammonium sulfate. Okay, write down the formula. Ammonium is NH4 plus 1. Sulfate is SO4. See, at the end it is 8. So it's a radical. Minus 2. Cross. So the balance formula is NH4 bracket 2 SO4. First thing, RFM. How? Nitrogen 14. Out of the bracket 2 means multiplied by 2. Hydrogen 1 multiplied by 4 to the 8. Sulfur 32. Oxygen 16 into 4. Let's add all of them together. 28, 18, 32, 64. So 28 plus 18 plus 32 plus 64. 142. My RFM of ammonium sulfate is 1842. Now percentage of nitrogen will be mass of nitrogen. How? What is the mass of nitrogen? See, I will not write only 14. 14 multiplied by 2 because there are out of the bracket there is 2. So I can write 14 into 2 or I can directly write 28 divided by 142 into 100. So 14 to the 28 divided by 142 into 100. The percentage is 19.71. 19.71%. Check another one. Later on, you can pause the video after every formula. Try to do it by yourself. Now, for example, calculate the percentage of nitrogen. Calculate the percentage of nitrogen in ammonium nitrate. Ammonium nitrate. All right, what is ammonium? NH4 plus 1. Nitrate NO3 minus 1. So they are balanced. So the balance formula is NH4 NO3. Nitrogen's atomic mass is 14 plus hydrogen 1, how many? 4 plus multiplied by 4 plus nitrogen 14 plus oxygen 16 multiplied by 3. So 14 plus 4 plus 14 plus 16, 3 is a 48. Okay. So 14 plus 4 plus 14 plus 48. 80. The RFM is 80. All right. Now percentage of nitrogen is equal to how many nitrogen are there in this compound? 1 and 2. And under them no number is written. 1 nitrogen here, 1 nitrogen here. So I will write 14 plus 14 because there are 2 nitrogen divided by 80 into 100. 14 plus 14 is 28 divided by 80 into 100. 35%. So children, in today's lecture, we have learned writing the chemical formula, calculating the RFM, and the percentage of any single element in a chemical compound. Those who have got in their exam only writing the chemical formula and calculating the RFM, they will learn up to that much. Those who have got percentage composition also, so they will add in their exam preparation percentage composition also. So that is all for today, children. The next video will be on writing and balancing the chemical equations. Bye bye.